Okay, now we're moving on to how to calculate the cross product, and it's definitely the more challenging of the two, and I'm going to do this a little bit different since I'm not in person going through this. The most common method that I see out there, and it's the most bulletproof, and this is going to get a little messy for your first one. What you do is we're going to write the u vector twice, so ux, uy, uz, ux, uy, uz, and do the same thing right underneath for v, vx, vy, vz, vx, vy, vz. And then what you do is you cross out the first column and you cross out the second column. And now, if you have a highlighter or a different colored pen, sure comes in handy here. What we're going to do is we're going to multiply uy multiplied by vz and subtract uz minus vy. So the result's going to be a vector. So we're going to end up with uy vz minus uz vy. And that's going to result in the first value. That's our x component in the vector. All right, so that's our x value. Make a bit more room here. Next, take my next colored highlighter, and now I'm going to multiply uz with vx multiplied by ux vz. So uz multiplied by vx minus, it's always subtraction, ux multiplied by vz. And that turns out to be our y coordinate, okay, or our y component, y value. Just bring this down. And there's our y component. And then the last and third one, and I'm out of highlighter colors, surprise, surprise, so I'm back to yellow. I would do, let's see here, oh, those are supposed to be crossed out. I lost my crossings, there we go. So now I'm down to ux vy minus uy vx, and that would result in our z component. So there would give us z. All right, so very, very challenging, and I'll show you a couple of numeric examples, and with numbers it's a little bit cleaner. However, I'll show you an alternate method, and this is it's a personal shortcut, and I'll show you how it works. Okay, what I always did for myself, I called it the 23, 31, 12 method. So I always had these values written on my cheat sheet, or I memorized them because I didn't get a cheat sheet in the day. And basically what happens is, in the vector, so u equals, let's just put a, b, and c. The v vector is d, e, f. Each of them get a designation. So numbered 1 through 3. So 1, 2, and 3. 1, 2, and 3. So the way I would do it, and you may look at this thinking, he's crazy, that doesn't work much better. What I would do is, the first time I would take 23, and I'll just write it underneath because usually I do it in my head. So I multiply 2 with 3. So the 2 is the first. This is my u vector, and this is my v. So number 2, so I would take b from the v vector, that's number 2, multiply it with 3 from the v vector. So bf minus, and then I'd switch it, 3, 2. And that would give me c times e. Then I have 31, so I'd have 31 and then 13. So 3, again, it's always in the form uv, uv, uv. So from vector u, I'm going to get the third term, which is c, and multiply it with the first one, d, always subtracting, 1 with 3, so af. And then the final one is the 12, which would switch to a 21, 1 with 2, so ae minus 2 with 1, bd. Okay? One's not better than the other. The second way that I just showed you, that's how I program myself. But many people will use this method, and I had most people doing it this way. It depends what you're more comfortable with and how you're quicker. This is more for people who are comfortable using mental math. It speeds up the process. This one's kind of that bulletproof, always works for you. Okay, so we'll run through a couple of examples so you get to see how it works. And I'm going to try to demonstrate both. So for the first one, you always love seeing an angle. And that's a great thing, because you know that u cross v is equal to magnitude of u, magnitude of v sine theta. We only have one equation that has the angle in it, of course. So now it's just 5 times 10 sine 30. And that's going to have a direction. And here's an example where that n indicates there is a direction. It's just with the information given, I can't provide which way it is, but it is a vector result. So there we go. That's it for that one. The second one, I'll show it with writing it twice method. So u cross v, and then you're going to have some rough work down below here. So 3, 6, 2, 3, 6, 2, and then negative 2, 4, negative 8, 2, 4, negative 8. You're going to cross out the first and last. And then you start multiplying on the diagonal. So 6 times 8. So I guess for the first one I'll run through full there. 6 times 8 minus 2 times 4. And you're going to get quick enough that you're not going to do this out loud. The next one, so 2 times negative 2 minus 3 times negative 8. That's your z component. And then we'll try to squeeze in the last one here. 3 times 4 minus 6 times negative 2. Now most people are going to skip that step, and they're going to go to this one, and they're going to say 48 minus 8, negative 4 plus 24, 12 plus 12, and you end up with 40, 20, 24. So that's your resulting vector. Okay? That would be your answer. So you end up with a vector, and that would be the answer. All right. People may be interested in doing it with that the 23, 31, 12 method. I'll show you what that would look like. So 23, 31, 12. So we'll do u cross v equals. So I'm looking at my second one. So negative 3 times negative 3 minus, and again I'm showing extra steps here. You're going to get much faster with this, I hope. So 2 of 3, and then I flip it, the third one, so it's a 5 multiplied by my second one, which is a 2. So again, the u column and v column for me. Next one, the third one, so a 5 multiplied by negative 7. Always subtraction, the first one multiplied by the third one. That's my y component. And 1 with 2, so 2 and 2, minus 2 with 1, negative 3, negative 7. All right, and again, normally I don't do that step. I'm just doing it for this example. I'm going to start skipping that step pretty soon. So, oops, positive 9 minus 10, negative 35 plus 6, 4, and that's going to be minus 21. So our final answer then is negative 1, negative 29, and negative 17. All right. So again, doesn't matter which method you use. I do warn you though, people let this slide, this particular topic, and they never get around to learning it properly. They pay for it big time in the next unit, because this is something you have to do, and you're going to be doing it several times in each homework day in Unit 2. So good to become proficient with it. Okay, so the example, determine a vector perpendicular to u and v. So we're looking for we have two three-dimensional vectors given to us. We need to find a vector that's perpendicular to both. Remember, this is right away, I'm thinking cross product, obviously because we're in this particular unit. But remember, with cross product, when you have a lever arm and a force applied to it, the force is going to come either in or out of the page, which is perpendicular. So the definition of a cross product is taking two vectors, performing the cross product, and the result is a new vector perpendicular to both u and v. So I can't stress that enough. U cross v creates a new vector, always vector perpendicular to u and v. Always. So that means to answer this question, we're going to do u cross v. So whichever method you're going to use, and it's, again, completely up to you, but we're going to speed it up a little bit more. So I'm going to have 3 minus 3 with 2, so that's -4, so that's +4. 3 and 1, so -1 minus, oops, I might have, no, I did that right. Now I'm second guessing myself here. No, I didn't do that one right. This is what happens now when I'm trying to rush. So let's make sure I did this right. So the second with the third, so that would be a 3, subtract 3 with 2. So that's not right. So subtract my third one with the second one. Oh, it would have been +4. I was right. Okay. Third one with the first, so that's -6 minus first one with the third, so it'll give me a +1. First one with the second one gives me +2, and the second term with the first gives me, make that +9. So the resulting vector would be 7, -5, 11. So therefore, 7, -5, 11 is perpendicular to both u and v. All right, and that's pretty much all the time I have for this. We'll finish up the examples in the next